These past few weeks I've been working on scaling up the world in my new project, Sacred Forest, which is an open world action-adventure game where you play as a pixel art bow-wielding heroine set within a diverse forestscape. It's developed in Godot 4 and you can even wishlist it on Steam right now. I'll leave a link down below. First of all, I just want to say thanks for all the support on the last video. There were a lot of positive comments about the game, which was really motivating. Also, there was some great feedback and a few questions of how I'm scaling up the game, so I'll try to address as much as possible in this video. Let's start out with the main character and the visual style of the game. I will say that I definitely will be keeping the pixel art characters and NPCs in the world, which seem to be a situation where you either really like it or absolutely hate it. But I personally like it, so that's the way it's gonna be. Having said that, I know there are a lot of improvements that can be made. For the actual design of the character, a lot of people didn't really like the face, so I went back and redesigned the head of the character, and I'm pretty happy with the changes. But let me know what you guys think down below. There's still a lot of animation work that needs to be done for the main character, but some of you pointed out that it would look much better with 8-directional movement. Previously, I had 4 directions, forward, backward, left, and right, and then rotated the character a bit for diagonal movement. But in order to keep with my goal of a strong visual style, I think it is definitely the right move to make a whole new set of diagonal animations. So that's a big part of what I've been working on. I created the diagonal run animations, and I think the character movement feels a whole lot smoother. In the future, I also want to add walk animations as well, since if you make the character move slowly, it looks a bit goofy with just the run animation. Many of you also pointed out that the character looked a little out of place in the world. I do just want to say that this world is a test world for me to test out the mechanics of the game and prove out the way I'm building everything, so that I know it works for when I design the actual game world. I have a very specific color palette that I'm abiding by for the design of the game, and the world didn't follow that palette yet, since I was mostly testing out the character mechanics. To try to bring the character and world closer together, I went ahead and retextured everything to follow the same color palette. Aside from the visual style of Sacred Forest, I've actually been doing a lot of audio work as well, since I feel like tying the visual and audio aspects of the game is extremely important for immersing the player in the world. None of the sounds you hear are final for the game. They're there as a placeholder for me to test out all of the systems. I mentioned before that I developed a spatial audio system with dynamic acoustics and made a tutorial about that, but I ended up completely redesigning that system since I felt like it was a little too basic for the game. Like the old system, the new system takes into account how big a room is around an audio source, and whether or not the audio is playing behind walls, and controls different audio filters to make the sound more believable. If I place the camera next to this fire, you hear the sound of it crackling, and it gets louder the closer you are. But if I clip through this wall here, when you're on the other side, it's just a muffled sound since the audio should be bouncing off the stone. The main difference for the new version is that it now takes into account what materials are around the audio source. For example, if the player is in this cozy wooden house with a rug, there shouldn't really be an echo in the room. But if the player is in a cave surrounded by stone, then it should echo quite a bit. I ended up using this new system to also add dynamic footsteps for the main character. The sound effects are placeholders, but just listen as the player moves from running on dirt to the wooden ground and then onto the rug. Each material plays its own type of sound. The last audio change I made was the character breathing in first person. Some of the feedback was to make this just a single breath instead of heavy breathing, and I think that totally makes sense, so I made that change for now. But I'll probably change out this sound effect sometime in the future. Now onto the major updates I've been working on, which all has to do with scaling up my world. Godot is the game engine I'm using to build Sacred Forest, and it's not really made to build out large open world games, but it is open source and there's a large community, so there are some pretty good plugins for the engine that can help with scaling up a world and everything in it. A huge challenge when building an open world game is making a detailed world that feels immersive to the player while keeping the game's performance high enough so players can actually enjoy the world you built. It's also extremely important as a developer to be able to develop the game without it being extremely slow as you scale up the world, since if you can't develop the game, it'll never be finished. Developing the game so that it stays optimized even as the world scales up is key to making an open world game. So what does this actually mean? Well, I'm gonna get a little technical, but I promise I'll bring it back in just a bit. A computer generally has a GPU, a CPU, memory, storage, and networking. The combination of how all of these are used together determines how a game performs. Sacred Forest is single player, so we won't worry about networking. Right now, I just want to focus on the GPU and CPU since it's important to understand how I'm scaling up Sacred Forest. The CPU is responsible for running all of the game's logic, things like NPC AI and pathfinding and listening to inputs from controllers or keyboards to perform different actions. It's a jack of all trades and can do a ton of different things. It can even do multiple things at the same time if it has multiple cores, which can run multiple threads. You probably have a CPU that has at least 4 cores and maybe could run 8 threads at the same time. So let's just say your CPU has 8 workers that can basically do anything you want.
We can do anything you want.
While the GPU is hyper specialized to only really do a few things but do them extremely well. While your CPU might have only 4 cores, your GPU has hundreds or thousands of these hyper-specialized cores that can all work at the same time, but they only know how to do a few things, and for 3D games, generally those few things work together to display all of your 3D visuals. Even though there are thousands of these GPU workers, they don't know how to do anything unless the CPU tells them what to do. In simple terms, your CPU runs all your game logic and tells your GPU to work on displaying everything in your game. The way your CPU does this is with a draw call, which means the CPU is asking the GPU to render a list of things in the form of triangles. For example, the CPU can submit a draw call to render this box made of triangles, but let's say we want multiple boxes. Well, the CPU could either submit 2 draw calls to render 2 boxes, or it can submit 1 draw call that asks to render both boxes. It's generally a lot less overhead to reduce the amount of draw calls by submitting as much as you can within a single draw call. The main goal for GPU optimizations for games is to reduce the number of draw calls and to reduce the amount of geometry you're trying to display at any given time. And the main goal for CPU optimizations for games is to reduce the amount of work each of your CPU workers have to do at any given time, usually by reducing the amount of work per frame or spreading your work across multiple threads. Alright, I know that was probably too much information to take in at once, but I feel like it's really important to understand why I'm using certain plugins, as well as custom systems, and how they're helping the game scale up. I'm gonna break Sacred Forest into 3 categories: terrain, foliage and decorations, and everything else. For terrain, I'm using the Terrrain3D Plugin, which allows for designing quite a large terrain with the built-in tools, as well as texture painting and navigation support. It scales quite well with its clip map system in combination with multiple level of details for the terrain mesh. This type of system greatly reduces the amount of geometry being sent to the GPU at any given time by only keeping the terrain at a high level of detail near the player camera and reducing the detail farther away, which is exactly what I was looking for. So terrain scalability, check. For foliage and decorations, I'm using the Spatial Gardener plugin by Dreadpon. This system allows me to paint things like grass and trees onto my terrain to build out my forest and decorations. I really wanted a system that allows foliage to be painted on instead of just generated, and it was really important to me that it uses multiple multi-mesh objects to reduce the amount of draw calls being sent to the GPU. It works by using octrees, so as the main camera moves through the world, only certain amounts of foliage are rendered at any given time with multiple levels of detail, and eventually removes the foliage completely at a certain distance. And that's tunable and even works within the editor. This system was exactly what I was looking for because it works quite well to reduce the amount of draw calls at any time by packing thousands of grass foliage into single calls, and it reduces the amount of geometry at any time by adjusting the level of detail, and eventually just removes the mesh completely after certain view distance. So foliage and decoration scalability, check. These 2 plugins work well with each other to scale up a world, but there's still the everything else category. In order to make everything else scalable, I created my own dynamic zone loading system. It's a multi-threaded zone system where I can create a zone for my game that is bound by a collision shape. Then I can add anything to be part of that zone, even subzones. Then the zone is baked into multiple files, and as a player leaves the zone, all of its contents are removed from the game, which is different than just making it invisible. and when the player enters the zone, all of the zone contents are loaded from all the files in a multi-threaded way, and then added back into the game. This even works inside the editor, so that while I'm working on something far away from a zone, it's not taking up any of my resources. Overall, this reduces the load on the CPU, because any NPCs far away will be despawned, and it reduces the load on the GPU because any objects that are far away will not be rendered, or even in the game's memory at all. This system was the last key to be able to make Sacred Forest the size of game that I want it to be. It won't be massive, but it could still be a pretty decent size and still run fine on most hardware. Sacred Forest still has a long way to go, but I'm really happy with how it's turning out so far, and I'm really excited to continue working on the game to make this game as good as I possibly can. Like I said before, I'll do my best to try to make devlogs when I have time, but I only want to make them when I feel like I have enough content that's worthy to talk about, so it would really mean a lot to me if you consider subscribing. Anyway, check out the Steam page if you want, or not. Until next time.